have recorded. Okay, see, Shreya, this is the structure of the four variable KMF. I have written to you many times. Again, we will recall. This is a structure of a four variable KMF, four variable map. Okay. So you can see the inputs can be any of the four variables. It can be A, B, C, D, W, X, Y, Z. Any four variables can be inputs. So the inputs will be divided as X, Y or W, X, Y, Z means W, X and Y, Z in other way. Okay, four variables. All the four variables are listed here. And the positions are mentioned here. The positions of the minterms are mentioned here as M0, M1, M2 and then M3, M4, M5, M6, M7, M8, M9, M10, M11, then 12, 13, 14 and 15. These are the positions of the minterms. Okay. So why do we want to know the positions of the midterm? Because in any question, we will be given the positions or the midterms like this way. Summation of all the midterms will be given and we need to plot these values. These positions are having 1. It means that these positions are high. So when there is M0, we have to make it as 1. If it is 1, it means at the position of 1, you need a 1. At 2, we need a 1. Okay, then 4. There is 4. This is 4. 4, there is a 1. Then 5.
How will you get to know it is 4, mom? Like in
this will be a question. So they will be giving you the midterms directly. And we should know the
okay.
Yeah.
Position, how we need to identify it is like 4 or 5 that I'm asking.
This is an order we are writing it, no? M0, 1, 2, 3, 4, 5, 6, 7. We are writing in an order. This order we have to memorize.
In this order I can understand, mom. I'm asking about like how did you mention it is 4?
This one?
In the box.
Here?
In the box.
In the box, how it is written M0, M1, M2?
Yes, mom, that one. 4.
Because see the M0 box is corresponding to 0, 0, 0, 0. It is nothing but the first number. Okay. Then M1 is corresponding to 0, 0, 0, 1. It means 1. That is M1.
Okay.
For example, you can see here M15. M15 is corresponding to 1, 1. It means 1, 1. And here also it is 1, 1. So it is going to be 1, 1, 1, 1. It is nothing but 15. Binary equivalent of 15. Hence it is called as midterm 15.
Okay.
Okay, for M8, see, for M8 it is going to be 1, 0. XY is going to be 1, so WX is going to be 1, 0. And YZ is going to be 0, 0. So 1, 0, 0, 0 is nothing but 8. In binary. You understood now?
Confused, mom.
What is that? You know what is that confusing? I will write on the full numbers W, X, Y, Z. These are the four variables, and we can number the name them as 0, 0. All the 16 combinations 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1. 0 1 0 0 0 1 0 1 0 1 1 0 0 1 1 1 then 1 0 0 0 1 0 0 1 1 0 1 0 1 0 1 1 1 1 0 0 1 1 0 1 1 1 1 0 1 1 1 1. They are nothing but binary equivalents for 0 1 2 3 4 5 6 7 8 9, 10, 11, 12, 13, 14 and then 15. Okay. So if we have four variables, we have 16 combinations. All the 16 combinations are listed here. Okay. So now this binary equivalent M0, this is 0.
By the combination only you will use this one, no, mom?
Yeah. With this combination you can verify here the positions, then you will understand. So this M0 is nothing but 0, 0, 0, 0.
There you will put 1.
Yeah, now this position is
Why
understood.
can't we put zeros in that square brackets, ma'am?
Because these are all min terms. Because they are, I said you in the last class, min terms are represented by using summation. Where whenever they give you this notation of summation, it means that these terms corresponds to 1. These positions correspond to 1. They are called as min terms. They are called
Okay.
as min
Mid
terms.
term.
Yeah,
The
those positions correspond to
which has
1.
one.
Okay.
The position which has one is called min terms.
Min terms, yeah, very good.
Okay. Zeros and all it is the max terms, ma'am.
They are called as max terms.
It's the you left one space, no, ma'am, in one that is equal to 0, no, ma'am.
Yes, it is equal to 0. These are all zeros.
Okay.
It means that suppose if 0, 1, 2, 4, only these are going to be high. So it means that the 0, this 1, then 2, 4, these numbers are going to be high. There is going to be an output at these positions. Remaining positions, there is no output. So it is going to be 0. There is no 3 means it means that at 3 there is no term present there. Okay. Similarly, there at 7 there is no terms, so it is going to be 0. The output will be 0 here. This term is not present. Like that it means. Okay. So now these are the positions. If you know the positions, you can mark these min terms in the K map.
Yes, ma'am. Position
Now,
means like
the place where you have to place this min terms. The ones has to be placed in the position of 0, 1, 2, 4. There all these positions must be marked with ones.
0, 1, 2, 4 means here 0, 0 is no, first one is 0, no, ma'am.
Yeah, 0 means this is M0 here.
In square bracket 0, 0 means after that it is 0, no, ma'am.
Yes.
Then 1.
Then 1. Then 1.
Then 2.
2 is here.
Where, ma'am?
Here I am drawing here, na? M2.
Okay. Okay, you need to follow this bracket.
That's all. These positions you have to follow.
Based on that, we have to remember this
Positions.
positions, no?
Yes, you have to
Then
remember the
we have to
position.
add.
Yes. Then we can place the ones in the positions.
Okay. Only 15 they'll ask, no, ma'am?
Maximum 4 variables. 4 variables are going to be 16 combinations. That's
Why here 15 became 0, ma'am, instead of 1?
where? This one.
M15.
M15 is here.
Yeah, downwards also. There.
Here it is 0 because it is not mentioned as 15 here. The min term is not mentioned in the position here. The question. In the question, whatever min terms are mentioned, only those min terms are marked here as ones.
1. Okay, remaining it is zeros. Now I understood, ma'am. This clarity I was asking.
No issue, no issue. Okay. So we have marked all ones first. All ones and remaining are 0. You need not mark zeros in the examination. Only ones can be marked because only min terms are given in the problem. You can mark only the min terms.
Okay.
Okay. Now, first one is marking the min terms. First one is marking the min terms. Second one is grouping. We have to group them. Group the number of ones. So now how it is grouped? Yeah, how it is grouped you can see. We have to group for maximum number of ones in a group. We have to group maximum number of ones in a group. So here I am seeing here these are all adjacent number of ones. These are all adjacent. So these ones can be grouped in a single group. They can all be marked as adjacent ones and they can be grouped in a single group.
Okay.
Okay, then what are all remaining? Remaining here will be these 3 ones. 1, 1, 1, 1. These 3 are not grouped still now. Okay. So how can we group them efficiently? We can group them like these 2 ones can be grouped with these 2 ones together. So these 4 number of ones will fall into one group. Because this cell is also adjacent with this cell. Similarly, this cell is adjacent with this cell. So we'll make them into one single group of having four ones.
Okay.
And one more one is left out without any thing. Like this one, no, we have not marked this one with any group. So to mark
After
this one,
module, can you give revision kind of thing, mom?
which module?
This module?
You have to pay extra because I'm taking more number of classes. Per hour 500 means it is crossing. Okay. If you need a revision again and again, then we have to pay. Because I have my classes, I have my earnings, everything falls into that. Okay. So it is not a problem for me to take classes for you. Everything will be accountable. That's all.
Okay.
Normally we teach and explain students all the concepts in the syllabus. If you want revision, then no issue. After completing all the topics, then you can schedule classes for revision.
Yes.
Okay. So this one which is marked in blue color, it is not marked in any group. In the red group or black group, this one is not yet marked. So we need to mark it effectively. Effectively means with other number of ones. So how can I mark it effectively? I can do it in this way. So I can group these four ones into one group. So now there are three groups. Now there are three groups, blue and then black and red. Okay. Now we have to write down the terms of the groups. Third one is the writing down the corresponding terms or expression. Write down the corresponding expression. So how to write down the expression? So first I will write it for this red group. Okay. The red group is having how many ones? It is having 4 plus 4, 8 number of ones. Now write down the corresponding W, X, Y, Z alone. Okay. So for this red term, you can see here W and X. These is varying. Totally it is varying. We have to look for which variable is not varying, which is constant. So we can see here in YZ, Y bar, Z bar and Y bar Z. Here Y bar is not changing. It is constant. It is not changing. That is why we are changing Y bar here. We are taking Y bar as the expression for this red one. Okay. Next for the black group. For this group, black group, how many ones are present inside that? 4 number of ones are present.
How 4, mom? It is 3, no, mom?
Here.
Okay, here. Left side. You
Yeah.
made it red, no, mom? That's why I got
That
confused.
is we are not able to understand. Erase it. So only when I draw blue, then I will take only this black one alone. Okay. So now we are writing the expression for this black one. These 4 number of ones. So what will be W, X and Y, Z corresponding to this group. So here it is going to be W bar X and then WX for these two. And for the vertically, when you see YZ terms, YZ is going to be Y bar, Z bar, and here YZ bar. Okay. So now we have to look for which one is not changing. So here X is not changing. So I will write X. And in YZ bar, in the Y and Z, which is not changing, Z bar is not changing. So I am writing Z bar. So this is how you write the expression for the corresponding groups. So now which one is left out? Still we have one blue group left out. So I will erase the remaining so that you will be able to understand it thoroughly. So now we have to draw for the blue group. Where is the blue group? It is here. It is corresponding to these 4 ones in a group. Okay, so now I'm going to write for the expression for this group. So look for WX. WX is nothing but W dash X dash, and here it is W dash X. Whereas here it is Y dash Z dash and Y dash Z. So which one is not changing in W and X? W dash is not changing. So I'm writing down it as W dash, and Y dash Z dash and Y dash Z. Which one is not changing? Y dash is not changing. So we have to write Y dash. So sorry, which is not here. This one I have tried on Y and Z dash here. So here Z dash is not changing, so we have to write down as Z dash. So this is the expression. The corresponding terms here or the group, and here we have to look over and we have to write down which one is not changing. So this will be the expression for the four variable K map. We have reduced the expression by using K map. So this method alone, you just keep it in mind how we are grouping the ones and then how we are writing the expression. That's all it means. Because in your question bank, we are going to implement these K map with other circuit designs. Okay, so when it comes to combination,
Implement means we have to draw the K map again, mom.
now I will tell you. Now we'll move on to that question so that you will be able to see what we are going to do. So we are going to see K map is over now. So we are going for the combinational circuits.
Yes, ma'am.
So if you are having your mobile, you check for, I think the question is present. Like you have to draw and implement half ladder and full ladder by using combinational circuits. That is a question in your second module.
1 minute, mom.
You check for that question.
It is y of 0, a dash, b dash, e to the power of n dash, mom.
Which one? Question bank, huh?
You didn't mention the question number, mom. You just wrote y dash of, y naught of 0, a dash, b dash, e n dash.
Oh, I need the question bank. I need to open the question bank. Wait, I will open it in my laptop.
Question bank you want me to share, mom? Notes, sir?
Question bank, yeah, you send me the question bank, no?
LD, mom?
Yeah, you have sent me already. You send me as a screenshot. This document is not opening in my laptop.
1 minute, mom. Will PDF open in mobile, mom?
It will get open in mobile, yeah. I have opened in laptop also. In my laptop, I have opened the document.
One minute, mom.
In module 2, this question number is question number 3. Not 3, 4.
I'm not wrong. I'm converting into PDF and sharing to you, mom, so that you can access through your mobile.
Okay.
I have shared you, mom.
All right. So in this PDF, module 2, the
Few questions will open it on laptop. I'll read, mom, because it was.
see, we have in the module 2, we have covered up to the second question. That is define combinational logic, explain combinational circuit with the block diagram, and give the procedure for designing combinational circuit we have completed. Okay. So today we are going to see about, I explain how a half adder and full adder differ in their functionality. Okay, this one question we'll see. Then we'll explain code conversion with an example. Sketch a neat logic diagram for BCD to XS3 code converter. These two questions we'll be designing today. Okay, we'll be covering it up today. So in that, now we are going to see the fourth question. What is the fourth question? You can take it down. Explain
How a half adder and full adder differ in their functionality.
functionality. Yes. This question only we are going to see today. How a half adder is going to be designed, and how a full adder is going to be designed, and how they differ in their functionality. That's all.
Yes, ma'am.
So we'll go to the thing. So now, so we are going to see what is a half
So
adder.
we don't have to write Karnaugh now, ma'am, for any question.
See, in the half adder design, we have got Karnaugh map. See, we need not study K-map as a separate question. But in all other designs, you will get a part, a portion where you have to use K-map.
Okay.
Okay, so at that point, you have to know the basics of K-map. Then only you will be able to do it. Okay.
Okay.
Okay, now listen. So what is a half adder? What is a half adder? Which adds 2 bits. Okay, well, it is going to add 2 binary numbers, 2 bits.
Okay.
Okay. So for example, the 2 bits are A and B. So there can be 4 combinations. The bits can be 0, 0, 0, 1, 1, 0, or 1, 1.
Okay.
That's the 4 combination of bit. And when you add these 2 bits, what will be the product? The output will be sum and a carry. When you add 2 numbers, you may get a sum and a carry. So I am giving the variable as S and T.
Yes, ma'am.
Okay, so what is sum? Just adding the 2 bits. 0 plus 0 will be 0. 0 plus 1 will be 1. 1 plus 0 will be 1. 1 plus 1 will be 0. Okay, so what will be the carry? 0 plus 0 will not have any carry, so 0. 0 plus 1 also will not have any carry. 1 plus 0 will also not have any carry. 1 plus 1 alone will have a carry.
Okay.
Okay, so this is the truth table of designing a half adder.
Okay, ma'am.
Okay, so first what we have done, the question is designing half adder and full adder. So half adder is nothing but which is an adder that adds 2 bits. So we have taken A and B as the 2 bits. We have drawn the truth table and the outputs are sum and carry.
Sum and carry.
Carry. And we have written the outputs also. When we add 0, 0, the output is going to be sum 0 and carry 0. 0, 1 are the inputs, so the output will be 1, 0. If the inputs are 1, 0, the output will be 1, 0. And if the input is 1, 1, the output is going to be 0, 1. So
Yes, ma'am.
this is going to be the truth table. The first step is that you have to draw this truth table. This question is there in your question bank. Okay.
Okay.
Now, second step, after drawing the truth table, what is going to be a second